Okay, so let's have a go at question 7 from today's paper, which is a trigonometry question. And I guess it looks a bit scary because it's got lots of stuff in here, but it's actually not so bad. So we're trying to find the values of x to solve this equation. So I'm just going to write it out first. So we've got inverse sine of x squared minus 1, which equals a third of pi. Basic rules behind solving equations is to do the same thing to both sides, and we use the inverse operation. So the opposite to an inverse sine is to do the sine function. So if I take the sine of both sides, I'm going to get x squared minus 1 equals the sine of 1/3 pi. And 1/3 pi is 60 degrees. Now in this case here, they said to you can give your answers correct to 3 decimal places. So you've got to watch out for how they've asked you to give your answers, because if they asked for your answers in exact form, you'd have to be careful. But in this case here, it's asking for 3dp, so that's all fine. So so if you take sine of 60 degrees, let's just work that out. I'll get my calculator. And make sure your calculator is, if you're going to do it in terms of a third pi, then it's in radian mode. If you're going to do it in terms of 60 degrees, it's in degree mode. Just be careful that you check your calculator each time. So for example, my calculator's in radian mode at the moment, so I'm going to put in a third times pi and do a sine of that. So I get 0.866 to 3 decimal places. Okay, so that means that x squared equals 0.866 plus 1, so it's going to be 1.866. I'm going to leave it like that just for now, because my next step is to take the plus or minus square root of this, and then I'll run around that final answer to 3dp. In fact, actually, probably what I should have done is actually left that one as way more detail and not rounded too early, so I don't make my answer too inexact by rounding too early. Cool, so I'm going to get plus or minus 1.366 according to my calculator. I'm just going to take this moment just to do something a little bit extra to this question, and that is to consider this here for a second as a special triangle. So a third of pi is the same as 60 degrees, and so a special triangle that has 60 degrees would be an equilateral triangle, so equal angles of 60 degrees. And if each side of that equilateral triangle was 2, like that, then I could split it down the middle to make 2 right-angled triangles. And if I take the left-hand right-angled triangle, for example, then the hypotenuse would be 2. The base would be 1 because half of 2 is 1. And this angle we know is 60 degrees here. Okay, 60 degrees, which is the same as pi over 3, or a third of pi. Now, we've done a few of these right-angle triangle things lately. So, for example, we know here that using Pythagoras, that side there would be the same as the root of 2 squared minus 1 squared. So that would be the root of 3. So, if I wanted to, when it asked me for sine of 1/3 pi, if I was actually going to keep my answer as an exact value, I'd set up my triangle like we have been doing before, and I would use that to get what the exact value of sine is. So, according to this, sine of pi over 3, which is sine of 60 degrees, equals the opposite over the hypotenuse. So what's opposite 60 degrees? Oh, it's pi over 3, and the hypotenuse is 2. So the exact answer would be root of 3 all over 2. And if you put that into your calculator, it's going to give you the same answer as what we got there. Okay, and on to part B. So we're asked to solve this pretty scary looking equation, sine 2 theta plus a third pi equals 1/2. for values between 0 and pi, and also giving our angle theta in terms of pi. So we want the exact answer for this. We can't just use our calculators normally and give it as three decimal places like we did in part A. Okay, so let's start off by trying to solve this anyway. So we're trying to isolate theta, so we've got theta equals something, so we should do the inverse sine of both sides first of all to get rid of the sine function. So if I take the inverse sine of that side, it cancels out the sine function on the left hand side, and that means I get the inverse sine of a half there. Right, so what we have to do here is we have to get this answer in exact form. So I jumped the gun in part A because actually we're going to use that same triangle now to find this exact value. So if you remember, we're using an equilateral triangle that's got sides of 2, and if I cut that down the middle, I'm going to get a right angle triangle. Has a base of 1, a side of 2, and this angle down here is the same as pi over 3, which is 60 degrees. Okay, so what we're asking ourselves is the sine of what angle is a half. So if I look at my triangle here, I want opposite over hypotenuse, the opposite to be 1 and the hypotenuse to be 2. So that would happen if I take it from this angle here. Because from this angle here, the opposite is 1 and the hypotenuse is 2. So what's the size of this angle here? Well, we've halved this angle at the top to make this triangle. So the angle before was 60 degrees. When we half it, we get 30 degrees, which means this angle here is pi over 6. Okay, so if we go back to our equation here, using the special triangle, we get that the answer is pi over 6. Right, but we need to be a little bit careful, and I want to show you why. So normally when we solve equations, you know that if I gave you an equation like sine x equals 0.8, when you solve that, yep, you'd take the inverse sine of 0.8, and let's say you're doing it in degrees, then the inverse sine of 0.8 is 53.1 degrees. But you would know that you have to find all the solutions. So if I'd said to you the domain was between 0 and 360 degrees, you would find not just 53.1 degrees, but you would do yourself a little sketch of that curve. And you'd say, oh, okay, actually there's two solutions. There's one here, which is the 53.1 degrees, and then there's one here as well, which is going to be 180 minus 53.1. So let's just quickly get that. That would be 126.9 degrees as well. Okay, so actually the same thing is going to apply here. So we have just solved an equation at this point here. We've taken the inverse sine of a half, and at this point I've only written down one solution, which is 1/6 of pi. But I actually should be writing down all of the solutions for myself. Same rules apply. So in this case here, my first solution is pi over 6, but my other solution is going to be 5 pi over 6. And how have I got 5 pi over 6? If I try to recycle this diagram down here, I've found one solution, which is pi over 6 here, and to get my other solution, I've taken pi as my point of reference, and I've taken away pi over 6 to move back in the same direction to find the other solution that equals half. Okay, so pi minus pi over 6 is 5 pi over 6. So those are the two possible solutions at this point for the inverse sine of a half. Okay, so let's keep going further. So I'm going to further try to isolate this so that I get theta by itself. So if I my next step is to take a third pi away from my two possible answers at the moment. So that means that 2 theta equals pi over 6 minus a third, which is going to be minus a third pi, and 5/6 pi minus a third, which is going to be 3 over 6, so pi over 2. Okay, so my next step would be to divide through by 2 so that I can find the answer for theta, but I'm just looking back at my domain and I can see my answers are supposed to be between 0 and pi, and I can see here that this answer's negative a third pi, so it's below 0. So I don't have my two solutions that I need. Okay, so what I could do, well, I could go further and tidy it up later, or I could go back up here and find another value that's equivalent, and then use that value to get my next solution, which is between 0 and pi. So there's two values here that I've got so far. These two values here are like the two values that are on this crest of the sine function. So if I wanted to find the next two values, they're going to be the ones that are over here, which is in the next kind of cycle of the sine function, which means that they're a whole 2 pi away. So to get the next two values, next value in this, all I have to do is take this value here and add on 2 pi. So if I add on 2 pi to pi over 6, I'm going to get 13 pi over 6. And if I carry that down here, if I take a third away from 13 pi over 6, I'm going to get 11 pi over 6. And that's cool because that answer is positive. So at least I'm in the right side of 0. So now if I divide through by 2, I'm not going to worry about that solution anymore because it's negative. When I divide pi over 2 through by 2, I get pi over 4. And when I divide 11 pi over 6 through by 2, I get 11 pi over 12. And both of these solutions here are between 0 and pi, and so I'm finished. If we just look back at it, let's say that you didn't fix it up where I did, and you kept with these two values and you divided them through by 2 down here. You took these two values and you took away a third from both down here, and you end up with pi over 3 and pi over 2. Then the other thing that you could have done to this solution is actually at this point here is you could add on 2 pi and you would still get the 11 pi over 6 as well. So I guess it's having that awareness that you're trying to find solutions that are between 0 and pi, and if you don't get solutions that are between 0 and pi, what can you do with your solutions to get them in that zone? And your two strategies are either to bump solutions up by using the period of the cycle, or to use the properties of the sine or cosine or tan function to find the other solutions. Something's gone wrong with my notation here, so I'll write out the solutions again for you. So they were pi over 4 and 11 pi over 12. And the other important thing I want to point out is, while at this stage here, the period of the sine function is 2 pi, so we can play around with our solutions by adding on 2 pi to find solutions that are in the domain that we need. Once we divide through by 2 down here, the period of our cycle becomes pi, because we're now adjusting it so that we're fitting in two sine curves in the space of what we had before. So down here, let's say you didn't spot that your solutions weren't in the right domain at this line or this line. You got down here, and then down here you found yourself with solutions that went between 0 and pi. You can still fix it up at that stage. You're going to have to use a combination of bumping solutions up by adding pi to them, because that's the period of sine 2x. And also then you're going to have to be careful about how you find other solutions. So for example here, remember for the sine curve, when we had one solution here, the other solution we found was by using like the symmetry of that crest. So subtracting the value off from 180 degrees. So you'd have to find that value for this curve to find the value that goes with it that's reflected across that sort of mirror line down the middle of the crest.